Hello everyone, my name is Subhashish Roy. I'm the head of training and development at the Indian Cybersecurity Solutions, and I welcome you all to a special webinar today. And today's topic is a very interesting one and very important one for your CCNA and CCNP studies as well. That is IPv6 transition mechanisms, dual stack and tunneling. So we'll be talking about the IPv6. We'll be configuring the IPv6 address also, and also I'll be talking about the tunneling. So let's begin. So we'll be talking about the IPv6 and what is the transitioning mechanism from IPv4 to IPv6. First of all, why is IPv6? Because we have had IPv4 for a long time. It is a 32-bit address. We all know it is a binary address, but it is not a very big address space. So we need a bigger address space, like ISPs distributing IP addresses, IPv4 addresses, and that is almost exhausted. So we need to have a bigger address space, and that is why IPv6 came. And IPv6 came with a very big address space, that is a 128-bit address space. Now we'll talk about IPv6 transition mechanism, dual stack and tunneling. Now, what about the transition? Because let's say way back in say 20 years back or 30 years back, yes, that was only a basic format of IPv6. Then the IPv6 first was introduced then. Now the infrastructure was not ready for IPv6. The router, the switches, the ISPs, they were not ready. So that is why we saw dual stack. Dual stack means IP4 as well as IPv6 address. Both are there in the dual stack. So in the router, it supports both, because if it supports IPv6, well, otherwise it will go for IPv4 routing. Tunneling is another way. Tunneling means that you have IPv6 on one place and say IPv4 on other place. So it is like the NAT. You want to convert between the IPv6 and IPv4 and again to v4 to v6. Transition mechanisms facilitate the integration of IPv6 into existing IP4 infrastructure that I've already told you. Dual stack allows simultaneous operation of both protocols like IPv6 packets, while tunneling enables IPv6 packets to be sent over IPv4 networks. So IPv6 was not fully developed then. So there were IPv4 networks, but IPv6 packets can be sent over that, like IPsec over GRE, if you say like that. Now, why transition to IPv6? Because exhaustion of IPv4 addresses that I've told you, IPv4 address is critical reason for transiting to IPv6, because the available IPv4 address space is limited. That is why IPv6 came. Increase in connected devices. Now, with the rise of the IoT, Internet of Things, and other connected devices, it has led to an unprecedented increase in the number of devices requiring IP address. Nowadays, let's say the people are using a lot more smartphones. So definitely each smartphone is having the internet connectivity and having a lot of IP address demand. Enhanced security features. IPv6 introduces enhanced security features such as mandatory IPsec support, that is very important for your network nowadays, which provides built-in encryption and authentication mechanisms to protect data integrity and confidentiality. So IPv6 provides you more enhanced features than IPv4. Then improve routing efficiency. IPv6 improves routing efficiency by simplifying the hierarchical structure of IP address, and it leads to reduced size of routing tables and enhanced performance for data packets. Then comes the IPv6 transition mechanisms. Transitions are crucial for facilitating communication between IPv4 and IPv6 networks. Now, it is like the bridging that I was telling you, that you have IPv4 on one side and IPv6 on the other side. It may be there may be another case, like you are having IPv6 on both sides, like the customers having the IPv6 over both sides, but in between the ISP is not having that. They are having still the IPv4 networks. It is like that. So this is for a smooth migration process. The two primary methods are there. One is dual stack and tunneling, but they serve different needs and scenarios. Like dual stack, there are two addresses IPv4 and v6, and tunneling means total translation. Now, what is dual stack? Dual stack is a traditional and transitional mechanism that enables devices to operate with both IPv4 and IPv6 protocols. This approach allows seamless communication across different network architectures. So, if you're having IPv4 and v6, it means that if I need IPv6, I'll go for v6. If I am compatible with IPv4 only, I'll go for IPv4. Then, what are the advantages of dual stack? Seamless connectivity across the protocols you have, no need for extensive upgrades. So, you do not need to upgrade your physical infrastructure or current infrastructure because upgradation means cost. So you can put the physical infrastructure in place, and if you're having IPv4, you can go for that. But if you're having IPv6, that is also welcome, and also facilitates gradual deployment. So gradually, you can also increase your infrastructure update, not suddenly. Then the challenges of dual stack means increased complexity in management. You have to deploy IPv4 and v6. Both you have to manage. Higher resource consumption would be there, and potential for misconfiguration. Like if you have done some misconfiguration, that would be disaster. Next, what is tunneling? Tunneling is a method that allows IPv6 packets to be encapsulated within the IPv4. So if your network supports only IPv4, so your packet is encapsulated within IPv4 packet, and it facilitates communication over an IPv4 infrastructure. This approach is crucial for enabling IPv6 traffic to traverse networks that only support IPv4. So there were the days when ISP was not ready for IPv6 that I was telling you. So in that time, only the tunneling mechanisms were there. Different tunneling was there, not only one tunneling. So it assists organizations in the transition to the newer protocol without requiring intermediate infrastructure upgrade. Now, what are the types of tunneling you have? One is the 6 to 4 tunneling. 6 to 4 tunneling is a method that enables IPv6 packets to be sent over an IPv4 network. So there is IPv6 and IPv4, all the addresses there on both sides, and IPv6 addresses are sent within IPv4. Then it automatically assigns IPv6 addresses based on the IPv4 address, allowing seamless communication. That is one tunneling. Another is pseudo tunneling. Pseudo tunneling provides IPv6 connectivity to nodes behind the NAT, network address translation device. So what does it do? It encapsulates IPv6 packets within UDP, user data protocol packets, and allowing the packets to traverse IPv4 NAT. So it is actually crossing the NAT because NAT does what? The private to public address translation, and pseudo tunneling actually supports that. So allowing the packets to traverse IPv4 NATs effectively. Because in IPv6, you do not have the NAT generally, but the pseudo supports that. Then another is iSetup. iSetup means intra-site automatic tunnel addressing protocol, and it is designed for automatic tunneling within a single site. Now it allows IPv6 packets to be transmitted over an IPv4 infrastructure in an organization context, so facilitates internal communication. So that is the iSetup tunnel. It is like the 6 to 4 tunnel, but in 6 to 4 it is having the dual stack and it is transitioning. It is not happening in iSetup. So these are the tunnel types you have, but Teredo and iSetup, it is a more specialized tunnel. Generally, we use the 6 to 4 tunneling mechanism. So this is about all the tunneling mechanisms and the IPv6 address, why the IPv6 came, and what is the advantage of IPv6 that we talked about. And especially we are talking about the tunneling mechanisms only here. So next is, let me go to the GNS3 console. As you can see, two routers are running in this GNS3, and already I have started the nodes. This is R1 and this is R2. So I have connected the routers with fastness 0 by 0. So let's go to the router console and give the IPs. Interface loopback 0. IPv6 address is 2001 colon 1, and you can give /128, that is IPv6 prefix. In IPv6 there is no CIDR, so it is only prefix. Interface F0 by 0, the physical port no short. IP address is 10.0.0.1 suppose and 255.0.0.0. And also you can create another loopback one, and here you give the IPv4 address, the dual stack I'm talking about, 1001 255.0.0.0, and then you have the router EIGRP is number one, and then no auto summary, and you have the network like 10.0.0.0 and network 1.0.0.0. So these two are added. And now go to the router 3 and means router 2 here, I think, router 2, and again give the IP address to the router 2 as well. So in the router 2, the same way we will configure the IP address here, like that is interface loopback 0, and we will give the IP address here in the hexadecimal format like IPv6 address 2001 colon colon, and let's say it's 3 or 2 by 128. Interface 0 by 0, physical port no short, address 10.0.0.2 255.0.0.0, and interface loopback 1 IP4 address 3.0.0.1 0 exit, and router EIGRP1 no auto summary, network 10.0.0.0 and network 3.0.0.0. So that is done. And now go to the R1 and give interface tunnel 0. This way we are actually creating the tunnel interface with tunnel source as loopback 1, that is the IPv4 interface, and tunnel destination is another loopback, that is the loopback 1 3001. You are taking the IPv4 only here, the address, and tunnel is up, tunnel mode IPv6 IP. So this is 624 tunnel. And in R2 as well, you go there and interface tunnel 0. You can give other numbers also. Tunnel source is loopback 1, and the tunnel destination is the 1001, and the tunnel is up. As soon as you give the destination, the tunnel comes up. Just check out. And tunnel mode IPv6 to IP. And there you go, the tunnel is up. And you can also check show interface tunnel 0, and you can see the tunnel 0 is up, line protocol up, hardware is tunnel, and source destination 3001, destination 1001, everything is there. So you can see that the IPv6 to 4 624 tunnel is already set up. So that is the way you configure the tunneling in IPv6. So that is the practical part I have shown you, and I have also told you the theory part behind this IPv6 tunneling methodology. And I think it was very helpful for your studies, this IPv6 tunneling. And this is short topic you can understand, because nowadays we do not use the tiling much, because gone are the days where the infrastructure was not ready. So that is about the IPC transition mechanism we have, that was very relevant in say 15 to 20 years back, but it is not so relevant right now. But still, for the CCN and CCNP enterprise, you have to learn the styling mechanisms. And as you know, that CCN and CCNP is in high demand today. And as a very senior technical trainer of Cisco technologies, I can say that it is in very high demand. I recommend everybody to you to learn the Cisco certifications, and I can personally teach you for the CCNB certifications for your goal to be certified. And also, I have a great news for you. I have a contest running on. I have also included a questionnaire with this webinar link, and there I have set 10 questions, very easy questions. And if you could give at least 8 correct answers out of 10 questions, then you will be eligible for a certificate. Just think about that. So you will have a certificate, and it will be invaluable for your studies for the Cisco certifications, for Cisco CCNA, CCNP, and also it will help you in your career. And also, there is another offer that you will get a flat 10% discount on courses if you enroll yourself today itself. So I encourage everybody to enroll yourselves right now. And definitely, I will meet you in classes for the Cisco technologies. So I hope that this topic, IP6 transition mechanisms, was very helpful for you today, and it will be very helpful for your goal to be certified for CCNA, CCNP, and also in your enterprise as a network engineer, you'll be able to actually incorporate these skills, and also you can do the transition mechanisms practically, because IPv6 is everywhere, but still, in some cases, maybe IP4 networks are there. So 6 to 4 tiling, at least, there is a need, and other Teredo or iSetup may not be used so much, but 6 to 4 is in use. So that is why I shown you that configuration. So I thank you everybody to attending and joining this webinar once again. So I come with some new topic next time. Till then, keep studying and bye.